Hi, my name is Aaron Stone. I work at Brightwell, recently acquired by Yahoo. We're down the street. We do smart video advertising. And I maintain Dashboard as an open source project now, I transferred out of Puppet Labs about 2 years ago. And I gave a talk at PuppetConf 2013 about that. You might be wondering what's going on with Dashboard. I had kids, so it's been a little while since I've had time to breathe. But I am actively maintaining Dashboard, and it's fun. You should use it. So let's talk about Dashboard, which is an ENC, as well as being a report processor, and external node classification itself, which is a great key piece of technology inside of Puppet. So brief agenda, what we're going to talk about, intro to the ENC, Dashboard, what else can an ENC do, and then what's new in Dashboard 2, and what's next. So what is an ENC? It's a script that's executed before the catalog compilation begins. The first argument is the host name. The output is a YAML document that includes some key information, and that gets passed into the catalog compile process. So it is roughly equivalent to a node definition in your manifests or site.pp, for example. And whoop, my screen is ever so slightly flipped. Oh, okay. So this is totally clear from the documentation, but here's the basic output that you would get from running the ENC, given the host name mail.example.com. It's going to come back having defined a couple of classes. These classes can be parameterized, and the ones that don't have parameters will just be instantiated. And then the parameters themselves will be accessible as global variables. Okay, cool, super simple, right? So here's how you configure it. You go into your puppetmaster.conf. You say node terminus equals exec, external nodes point to the external node script. It doesn't have to be in Ruby just because Puppet was or partly is. You can write this thing in any language that you want, and it can do anything. So that's going to be a key observation here. Okay, so let's have another topic a little bit. Let's talk about the dashboard. So the dashboard is as an ENC. As you saw in the Puppet Enterprise discussion, Enterprise is this much bigger product that has kind of the history of Dashboard is one component of it. Has a concept of node groups, and then nodes are members of their groups, and then groups will add in variables and classes that will then apply onto those nodes. Those classes can be parameterized at the node level or at the group level as well. And you can set up parent-child relationships between groups so that you can have, very similar to like, manifest A inherits manifest B, you could have group A inherits from group B, and then adds a bunch more site-specific parameters, for example. Here's a quick screenshot. So as you see, we've got a lot of host names. They're reporting in. And then down the left side, we've got groups, and you can see it was cut off that there are classes. And I'm not going to go into a deep demo of it. Hang on. All right. Let's come out of slideshow mode for a second. Start again. There we go. Cool. See if it gets, yeah, the screen size. Sweet. Okay, we can see the bottom line of text now. Okay, so as I said, key observation, an ENC can do anything, right? So typically, you might name something like my foo app serve 123.sitename.example.com. And in your site.pp, you'll regex off of that, and you'll say, okay, I'm going to go ahead and apply the foo classes in order to install the foo application. And oh, look, it's in a given data center, so I'm going to apply some East Coast, West Coast, Europe, what have you, regional configuration onto that host, and then go ahead and build the catalog with those items. You could also do that in ENC and have the ENC make those observations about the host name and then put forth that set of classes. But let's imagine for a moment that what if you just named all your servers very generically? Okay, well, how are you going to figure out what this thing does? So your site.pp could have a whole pile of listings saying, okay, server 123 and actually is running service foo, and server 456 through 789 are running service bar. Or you have that information stored externally. Now the ENC can go look that up for you. So this host checks in, it says, hi, I'm 123.servers.example.com, very generic based machine. And the ENC goes out to its external database or other web services that it wants to consult, says, well, what's this supposed to do today? And then goes and finds an appropriate catalog that's going to install the set of services you want running on that server now. Okay, So we'll kind of tie it together, right? So let's put together a whole provisioning system now. So we've got a workflow. We're requested to add capacity to the FoodServe application. Maybe that request came from a product manager who says they're launching a new service, they need X number of additional QPS because the internet is going to love this thing. Maybe that's an automated process because you have a monitoring system that's saying, hey, we're running at 60% of capacity, we try not to ever go above 50%, let's spin up a couple more servers. Okay, so your provisioning tool, you could imagine for a moment it's an admin at command line. You could also imagine that it is tool A communicating to tool B saying, okay, we need capacity. And basically this would be your own implementation of what Amazon calls elastic scaling groups, but what if you're using multiple cloud providers? You want to implement it yourself, maybe you're just going to not invent it here kind of shop. The tools for doing this are here. So the admin uses the tool, creates the instance, we capture its auto-assigned hostname. We don't necessarily have to give it a friendly hostname that says, hey, this is the foodserve27.US West. We could just say, this is I12345, and then go from there. We're going to capture that hostname, we're going to stuff it into the dashboard, we're going to put it into the FoodServe group, it's going to inherit all the parameters of the FoodServe group. We don't have a special hostname, we have a generic hostname. This is cattle, as the servers are cattle. So how are we going to get it there? Okay, well, EC2, you have user data. Most other cloud systems, you have some mechanism where you can pass in some configuration at the time that you launch the instance. That configuration is going to point at, hey, go run Puppet, but make sure to talk to my particular Puppet master where you have your ENC configured. You've got Cloudinit set up in your instance, so it's going to run Puppet on the first boot, and then, bam, gets classified when it first runs, continues being classified as it lives forward. Same workflow could apply to physical hardware as well. I'm going to sort of link dump name drop here. Puppet Enterprise has Razor. There's a tool called the Foreman that also does service orchestration for Pixie and DHCP booting for data center to do bare metal installation. And all of these will, of course, run Puppet as soon as the bare metal is up and running. Ask your neighbor what they're using. A lot of homegrown solutions out here. And generally converged around the same sort of like service orchestration best practices, but you never know, you might find something really interesting in the crowd. Okay, so following up from this cool Docker talk, and I'm like watching this talk, and I'm like, yes, totally gonna tie in. Bit of a digression on containers. So everyone's looking at Docker, right? And then you even have the CoreOS people who are like, Docker is too monolithic, we're gonna have our own tool that's gonna be exactly the same, but not Docker, because we're CoreOS. So we see that this is a general technology that has a lot of interest, and then we're all trying to figure out how we're going to use this technology in real production, kind of our day-to-day lives, right? So Docker is an interesting shift in power, right? So operations were like, okay, the developers have an application, it's going to run a couple of ports, X number of machines, here are what the thresholds look like for running the service, we'll write the Puppet manifests together, we'll deploy it, great. But then the developers and the packaging people get together and they're like, here's this thing, run it for me. So on the one hand, that should raise everyone's hackles. We're like, well, what's inside of this thing? What's it doing? It's just chewing up CPU, eating disk, I don't know what's going on. On the other hand, take a step back and just imagine now that your servers themselves become the infrastructure for enabling your developers to just deploy stuff. And then at scale, get it even bigger, right? Okay, so we've got this Docker file, we've got this image. It's just a PID, it's a black box. But don't worry about that. Okay, how are we going to figure out what we're running there? So we've got tools like Mesos, we've got tools like Swarm, but I want to also pitch the idea that you can build an ENC that'll handle this for you as well. So if you have a class, a Puppet class, and it's going to launch a particular Docker file, then figuring out which servers are running that class becomes a place where the ENC can jump in and help out. So we can say we have X number of servers of a given machine type. Let's say we've grouped them all up by machine type in our dashboard. And now we can say, okay, I need 5 of these, and I want them to be running this container, and this other container, and this third container on the side. And those will be items we'll just manage the containers as black boxes. But then we also need a base OS that's going to provide a lot of key services, right? We need monitoring on there, we need IPMI tools on there, we need to make sure OpenSSL are up to date on the base image, right? So this is something where we can leverage Puppet on the base server, get the right Docker files and containers running on that server, and then see how many of a given thing we're running at the ENC level, and tie it all together there. Okay. So this is sort of like just an idea, but also, as we can see from the prior presentation, from where some of these things are going, this is actually an avenue and sort of a question of like, has anybody tried this? Show of hands, although in the previous presentation we did say show of hands, number of people using Docker in production. Not yet, we're getting there. Okay. And let me bring back to dashboard. So digression on containers is coming back. What's new in Dashboard 2? Dashboard 2, if you're still running the Dashboard 1.2, because that's the last thing for which there were RPMs or debs, I have not packaged Dashboard 2 as RPMs or debs that are downloadable. There are, however, all of the definitions for running that packaging and locally. I don't think I'm going to provide binaries, because that's a lot of work. I'd rather maintain the source. Round runs on Ruby 187, 9.3, 2.0, and 2.1, and has much improved REST APIs. So creating nodes, adding parameters to nodes, creating groups, adding parameters to groups. All these things are now API accessible in Dashboard, which means they're API accessible from your ENC script. So you can do all kinds of neat stuff when a host spins up. You could, for example, observe this is the first host in a new data center. And you might actually act on that. Say, okay, let's create a new data center definition inside of Dashboard, and then begin assigning hosts into it. Lots of bug fixes, new UI tweaks, and ongoing maintenance. So not a lot of commits in the GitHub repo, but I'm super accessible and available. So pull requests and issues are acted upon pretty quickly. Upgrading, not at all painful. Hit favorite Ruby version. We now rely on Bundler as well. And to the terminal, clone the files, do a bundle install locally, and then copy over your configs, run a db migrate, super simple set of migrations, just a couple of additional things, and a bunch of performance tweaks as well. So if you were having performance problems with old Dashboard, a lot of those are resolved in Dashboard 2, not all of them. The reporting schema is still pretty terrible. That's on my next list. And bundle exec Rails server, so it'll run under thin or under passenger or any of a number of rack containers. What's next? All right, so far, where have we been? It's migrated out of Puppet Labs over to my GitHub account, and it's in great shape. The final branch in tag of 2.0, sorry, I haven't slept in a while, but I'm gonna take care of that pretty soon. And a lot of neat things in line for 2.1. As I'm getting some feature requests and some code submitted, and have a coworker who's like super stoked on working on the project as well. Improve the report storage schema, figure out if I can move to Rails 4. There are a couple of gen dependencies that might be a real nightmare here. Ruby 2.2 support should come for free with Rails 4. Now I know that Puppet itself is moving off of like MRI Ruby, which is sad because MRI Ruby is finally getting fast enough, but so it goes. More features, pull requests, welcome. Thanks. And then questions or comments. Let me actually jump over to, I want to show some code for, here's, for example, when we start out the typical external node, right? It's sort of the base image that comes with Puppet Dashboard. And what it's going to do is get some SSL certificates together, and then here we're going to find your dashboard URL, set up a GET request, and then do a GET against the then argv.first, so first argument passed on the command line to the script, and then Puppet Dashboard /node/hostname. Okay, that'll return a YAML document. But let's look at something deeper that we can jump in there, and we can start saying, hey, let's actually, if we don't find the host, let's create the host. Not only that, but we can merge in a whole pile of attributes. So we have node name, assign some group IDs, class IDs. We can, in fact, even scrape the dashboard for node groups and node classes.json, pull those down, and then here put together a hash, and then go find which of those that we want to be using. So really sophisticated classification schemes can be written in code. And you can interact from the external node classifier with multiple web services. In fact, in this particular file, I also have a Formic client in here. So it pulls in the physical host definitions, it then pulls in the application host definitions from dashboard, mixes them together, produces a host definition. And that's all. Cool. Jump back to my questions or comments. Okay. Thank you very much.